Chapter 1, Section 3 is about organizing our data. When we organize our data from our experiments, we will make a graph. And one of those graphs can be a line graph. And this is where you display data that changes continuously. There is an independent variable and then a dependent variable. The item being changed is the independent variable, and that's the one we would change. And the dependent variable will be the item that changes based on it. Bar graphs are going to show single values for many items. They're useful when you want to compare similar data for several individual items, like the size of our bubbles. When we used the one type of gum, we compared those items. Pie graphs are when you display items of data for parts of a whole. So it has to be from one whole or 100% type of data. Scientific notation is when we express numbers or values with a number times the 10 to a power. So 2 times 10 to the power of 8, or 3 times 10 to the power of 4. We are going to work with calculations, and sorry about the spelling error there, calculations using scientific notation on page 25. We'll do those problems 1 and 2 and 1 and 2. Now, significant figures show the precision of a measured quantity, and we'll work with significant figures tomorrow, but they show the precision. So precision is how closely you measured an item. So if you measured it to the millimeter or the centimeter, like we were doing with finding our volumes, our length, width, and height of our boxes, you will be able to use significant figures to determine where to round your numbers after you've measured them. When we use our significant figures, that will tell us which decimal place. So prescribed decimal place that determines the amount of rounding off that you'll need to do. Then when we multiply and divide these numbers, you know how sometimes you multiply and divide and then you get these long decimals? Well, we're going to use our significant digits to figure out where we are going to round that. And we'll do some examples on page 27, and we'll do some activities and some labs with this. Now, some of the words that we used in there was precision. So precision is the exactness of measurements that you make. So if I measure my height 3 times and I get that I am 5'3" every time, that's precise. Accuracy is how close those measurements are to a true value. Now, I am exactly 5'3", so if I get 5'3" 3 times, that's precise. But then when I compare that 5'3" to an actual known value, like what they measure me at the clinic, then that is accurate. And we'll do some practice problems with that. But that ends this section for our notes.